Hello and welcome. In this video, I would like to just give a brief introduction to what the course is going to be about. I'd like to also introduce a few different software packages, some websites, different resources that you can look to if you are struggling, maybe just some rabbit holes to go down if you're just a really curious person, and also some of the things that are going to be used over and over again in the course, and things that are used over and over again in quantum computing and quantum machine learning. So the first thing that you're going to need for the course is to download Anaconda. Anaconda is free, it's open source, you don't have to pay anything for it. It's used a lot in machine learning, data science, programming, different things like that, and it has a lot of useful software libraries and packages and things that come with it. The primary thing that we're going to be using is Jupyter Lab, and that comes with an installation of Anaconda. So just Google Anaconda, head over to their website, download it, and you'll want to, pick whichever version you're using, either Windows or Mac or Linux, whatever your machine is running currently, and you'll want the newest version of Python. So get the Python 3.7 version downloaded on your computer, and it probably has some kind of program or something in it that will figure out what your computer is running just by going to the website. So I just clicked on the download and it just downloaded the right version for my computer. So it's super easy to get, it's free, you don't have to pay anything for it, and it comes with pretty much everything that you're going to need for the whole course for programming in Python. So check out Anaconda, download that, get that going. Once you've downloaded it, it'll give you a little button like this, and you can open up Jupyter Lab here. Okay, and Jupyter Lab is what we're going to be using for pretty much everything throughout the course. And Jupyter Lab is just a really nice interactive notebook type thing that you can run Python code in. And if you've never seen Jupyter Lab, this is more or less what it looks like. You have like a file browser over here on the left, and then here you can type things in. You can type in Python code, you can type in markdown cells, which is sort of like a stripped down version of HTML. If you know what HTML is, you can type in markdown code, and it'll render the markdown code for you. And it'll let you do nice mathy, scripty type things. You can type things like this into markdown that have something called LaTeX code, which lets you script up math stuff to make things look really nice. And yeah, it just lets you make really nice documents and things like that, and also type in Python code and execute Python code. So Jupyter Lab comes with Anaconda. Once you've downloaded Anaconda, you can open it and launch your Jupyter Lab notebook, and you'll get something that looks kind of like this, but it'll be blank, of course. The next thing that you might want to do is hop over to GitHub. If you've never used GitHub before, it's not strictly necessary, but it's definitely a useful thing to get familiar with. There's a really nice tutorial on GitHub that shows you how to create a GitHub repository of your own. It shows you how to do pull requests and things like that, how to create branches, which is really good for coding. If you are in any kind of software development, you've probably used GitHub before, and so GitHub is just a good thing to become familiar with if you're going to get into any kind of programming or software development. But it's not strictly necessary for the course, so if that's not something you're interested in getting familiar with, don't worry too much about it. I will be posting some resources to GitHub, so if you're familiar with GitHub, or if you're a bit curious and want to go look at the GitHub repos that I have with some different resources, I will give references to my GitHub repo that has quantum computing, quantum machine learning stuff, and a few other things that are related and somewhat tangential. So check out GitHub. And the next thing that you're going to want to check out is PennyLane. PennyLane is a software specifically for quantum machine learning. And so quantum machine learning, if you don't know what that is, maybe now is a good time to explain that. Machine learning is kind of the foundation for artificial intelligence. I mean, there are some more algorithmic type approaches to artificial intelligence. Sometimes they call it like good old-fashioned artificial intelligence, which incorporate a lot of sort of instructions on how to do things. But machine learning is, I think, probably more important in a lot of cases to artificial intelligence because machine learning is very independent. You don't have to tell it what to do as much. It kind of figures things out on its own in a lot of ways. And it's also just really super useful in a lot of applications and things. And if you're looking at trying to get into machine learning and applying machine learning to different kinds of problems, and you want to like really solve a lot of different kinds of problems, machine learning is super useful. And quantum machine learning is basically just machine learning, but enhanced by quantum computers. So if you're interested in machine learning and you're curious about quantum computing, quantum machine learning is just the crossover between the two. And that's what the course is going to be about. We're going to talk about how to do quantum machine learning. So in the course, you're going to learn a lot about machine learning, and you're going to learn about quantum computing and the mathematics behind it, how to use Python to program your own code and create your own models, and how to just kind of bridge the gap between quantum computing and machine learning and make those two things work together. So so we're going to talk a lot about machine learning stuff, we're going to talk a lot about quantum computing stuff, and we're going to show how to tie those two things together to get quantum machine learning. PennyLane is free, it's open source, you don't have to pay anything for it, you can use it with, there's nothing you have to pay for, anything like that. It's completely free and open source, which is great. And one thing that I was a little hesitant about at first was, when I heard free and open source, I thought, okay, well, maybe this product isn't going to be that good because if I'm not paying for it, then there must not be, a lot of support, or maybe the documentation isn't that great, or maybe it's not that well developed, or maybe there's, just a lot of, I don't know, issues with the code, or maybe it's not consistent and there's like errors and things that I'm going to run into. And, when I first started learning how to use it, I wasn't super familiar with Python coding. I coded some in Python when I was an undergrad many, many years ago, but I hadn't really done a lot of programming more recently, and so I was super rusty and unfamiliar with programming. And when I heard free and open source, I was like, oh gosh, this is going to be a nightmare. But it turns out PennyLane is not a nightmare. PennyLane is actually kind of wonderful, and I am thoroughly impressed by it every time that I use it, for many reasons. It has a lot of really good introductory material, a lot of really good explanations. It has a lot of tutorials, a lot of educational material that helps you get started. They have like pre-built models that are super easy to understand and super easy to start using. And a lot of times you don't even really need to understand everything that's going on to use it, because it's just kind of ready to go. And so it's really good for introductions into both quantum computing and machine learning, which I was very happy with. The documentation is great. They keep it really up to date. They keep it super clean and very thorough. And so if you're like, trying to figure out how to use a certain function and in the PennyLane library, or you're trying to figure out how to code something, the documentation usually has a really good explanation of how to use things and how to put things together. And there's usually a pre-built example that can get you started, at least, that you can just modify if you're not really good at coding or something. So I'm super happy with PennyLane. I highly recommend using it. It's really great. Another thing that's really great about PennyLane, so you can click on these tabs. There's the Learn tab, which has a lot of like tutorials and reading material that you can look at. And let's see. The other thing that I like about PennyLane is it incorporates a lot of other software. So if you're not familiar with quantum computing, there are a handful of companies out there that have been researching quantum computing for several years now. Google is probably one of the biggest names, but other companies that are also looking into it that are also pretty big names and have been doing it for a while and have put in some really serious time and effort into researching quantum computing and actually building quantum computers. IBM, Microsoft. There's some startups out here in California that are doing it, like Rigetti. And you can see different companies like Amazon that are starting to hop on board now, that have partnered with some other companies doing certain kinds of quantum computing. And so PennyLane just really like takes all these different software packages and libraries and things like that that these different companies have developed, and it makes them to where you can integrate them in one place. So you can import things like Google Circ, which is a software that Google has for their quantum computers, and bring them into PennyLane and use them inside of PennyLane. And you don't have to go to 10 different places to get all these different kinds of software. PennyLane lets you kind of just put them all in one place. And they also let you use different kinds of machine learning software. So a really popular machine learning software is TensorFlow. Another one is PyTorch. And you can integrate these in PennyLane code, and they kind of work together, right? So PennyLane's a really good way to find documentation and example code and tutorials so that you can integrate machine learning models and quantum computing software that's kind of floating around out there in the ether and bind them together and make useful things. So yeah, again, we're going to be using a lot of PennyLane. We're going to be using a lot of Python in general, and I highly recommend just hopping on and looking at PennyLane's website and looking through some of the examples and going through some of the code and stuff like that and just playing around. There's a lot of stuff that's super user-friendly and just makes it all feel very doable and less daunting. And there's also Strawberry Fields, which is kind of like, it's by the same people that created PennyLane, but it's built more specifically for a special kind of quantum computing called photonic quantum computing, which is using optics. And we will probably get into some of that as well. And it might be good for you guys to just, go over to Strawberry Fields and look at their website and check that out. Something else that I recommend looking at and playing around with, just to get a visual and to have some visual representation and visual aid for quantum computing, is the Quark Quantum Circuit Simulator. So if you Google Quark Quantum Circuit, it should pop up, and that takes you here. And they have YouTube tutorials, and you can go to their GitHub and see their source code and things like that. And what it is it's a circuit composer, which gives you a circuit diagram of a quantum computer. And we'll talk about those and explain what those are and how to use them, how to interpret them, how to turn them into code in Python, how to turn Python code into circuit diagrams, how to turn circuit diagrams into linear algebra, and how to turn linear algebra back into circuit diagrams and things like that. Like, We'll talk about all that stuff throughout the course. But if you go to Quark, and this will pop up, and you can look at some of their examples. So let's do the quantum Fourier transform. This pops up, and this looks a little daunting, but you don't need to understand this right now. It's just a nice little visual to look at. But basically what's happening here is qubits are getting fed into this circuit diagram, and they usually call this a circuit composer because it looks kind of like a musical staff notation with the lines running across, and the little gates kind of look like musical notes on a musical staff, which I really enjoy. And if you scroll over, these little round things here are called block spheres, and they're supposed to represent what the qubit is doing at any given time, and how the qubit is changing depending on what gates are acting on it, and showing you like what the qubit states are in the circuit diagram. We'll talk about all of those and what these gates are, what they do to qubits. We'll talk about the block sphere representation of qubit states and how to interpret that in the course. But this will be good for you to look at and play around with if you get curious, or if you have a circuit that you've composed and you want to see a visual representation of it, or if you have Python code that you want to turn into a circuit and you just want to build something quickly, you can hop over here, and this lets you interact with it. You can drag these things around and move them to different places and add them and subtract them and delete them and things like that. So yeah, so this is Quark. You should check that out. And the other thing that you'll want to check out is the quantum computing that IBM has, because IBM lets you actually run quantum algorithms. You can compose quantum circuit algorithms, and you can run them on IBM Quantum computers. So if you go over to just Google IBM Quantum, and their website will pop up. And if you go to their website, you can sign up for a free account. Everything's completely free. Sign up for a free account, and I'm just going to launch it. So I've already signed up for an account, so I don't really have to sign in or anything. It just opens it up for me. But if you sign up for an account, you'll see this. And this is a list over here of the quantum computers that you can run your code on if you want. And if you click on one of them, so let's click on this one, it'll pop up and it'll show you what the qubits look like, how they're laid out on the quantum computer. So these little circles represent qubits, and the arrows between them represent how they're connected to each other in the quantum computer. And you can see, if you look at these little colored bars here, this tells you what the error rates of the qubits are. So like the darker the color of the qubit, the more errors you'll have for this particular quantum computer on that qubit. So like a single qubit U2 error, which I'll explain at a later point what the U2 operator is, and then there's a C0 error rate, and C0 is another kind of quantum logic gate that gets applied to qubits. It gets applied to 2 qubits. But this tells you what the gate error rates are on each of the qubits, and how the geometry of the quantum computer is laid out, and how they're connected, how the qubits are connected together. And you can create a notebook and code in Qiskit, which is IBM's language for programming quantum circuits, or you can do the interactive version by clicking on the Create a Circuit. And if I create a circuit, it'll bring me here, and this is another circuit composer very similar to the Quark circuit composer. It's more or less the same. You can add qubits here, you can drag and drop the gates and put them on the staff notation for acting on qubits. You can delete them. You can create things like C0 gates, which act on 2 qubits, different things like that. So we'll talk about how to use circuit composers, how to read these circuit diagrams and things like that throughout the course, and understand how to convert these into linear algebra and how to convert linear algebra back into circuit diagrams and things like that. Lots of cool stuff. So, check out IBM's Quantum Experience. Go sign up for a free account with them. And, we'll look at how to use PennyLane to run code in PennyLane on an IBM Quantum computer. So you can actually use actual quantum computers to run your algorithms. And we'll look at how to do that in PennyLane, how to code these things up in Python, and do some actual real-world quantum computing that's not just, theoretical in a textbook. Okay. So I think that's all for this video. This is just an introductory video to show you what resources we're going to be using, show you what things we need, what things are going to be used for the course. I suggest playing around with all of these some, just spend some time with each of them, checking them out. The thing that we're going to use the most is Jupyter Lab through the Anaconda, so definitely download that. Absolutely must have that. And then inside of the Jupyter Labs, we're going to use the PennyLane. I'll show you how to import PennyLane into Jupyter Lab notebooks. And we'll run our code on IBM Quantum computers. So go ahead and sign up for a free account at IBM and play around with that stuff too. And we'll be getting to that eventually.